Hello everybody, this is a mini lesson video for 2.16, which is about coordinate proofs. And there's not a lot of new information here, but we're really just taking information and that we've had already this semester, and then also information from previous years in a math classroom, and we're kind of putting it all together. Okay, remember we've talked about how the big picture of geometry is being able to take the information that you've learned in the past and justify it or prove it, okay? So that's where these coordinate proofs come in. One thing about these coordinate proofs that we always need to be mindful of is that we always need to try to place one point of the figure at the origin 0, 0. And notice that with the square here and the parallelogram and the right triangle, they all have a point that is located at the origin, okay? They all have a point that's located at the origin. Here, there, and there. Just briefly talking about it, remember that with a square, we know that all the sides are congruent, right? So if they tell me that the coordinate right here is A0, then that means that I had to go over A amount of spaces to get to that point. And I didn't go up or down any, so that's why my Y is 0. Now, since this side is A, this side would also be A, this would be A, and this would be A, okay? Be mindful, though, that whenever they found the coordinate right here, the X value didn't change, okay? It didn't go left to right any, so that's why my X is 0. But I went up in the Y direction the length of A. So that's why that coordinate right here is the coordinate 0A, okay? And then, of course, this coordinate here is AA because we had to go over A and then up A. Kind of sounds silly, but if I were to put a number instead of the letter A, I think it'd make total sense then, right? Like if this side were a 2, then this coordinate would just be at 2, 0. And this one would be at 2, 2 because you had to go over 2 and up 2. That's all that means. It's okay that it's a variable. Looking at the parallelogram, this is the one that can give people a little bit of trouble. Remember that the opposite sides of parallelograms are the same, okay? Like this is the same, and then this guy is the same, okay? So if this is to get from the origin to this point here, I had to go over A, which means that this length is A. But the actual coordinate point is AB. And that's because, let me grab another color. To get from this side to here, it had a distance of B. And then I have to add in the A. So therefore, the coordinate point over here would be A plus B. Okay? That's the biggest hurdle that people have with a parallelogram. The next one is this right triangle, and this just tells you that you started your 0, 0, and you had to go over to the point A0, so that length was A. But then for this coordinate up here, you had the X was 0 because we didn't go to the left or right, but you went up to B, so the length of that side would be B. Okay, that's all that means. So let's find the missing coordinates. So we're given this isosceles right triangle. So isosceles means that the things are congruent. Those sides are equal, right? We want to find the missing coordinates for B. So notice that the point A went to 3A and then 0. So my X value is 3A, which means that I had to go over 3A. Now, if this is an isosceles triangle, then that means that those two sides are equal to each other. The two sides will be equal to each other. So this guy, that side would be 3A. Now, when we go to write these coordinates, we have to be mindful of the X, Y, okay? Remember, we started our origin. We don't go to the left or right any when we went up here to point B. All we did was go up. So since we did not go to the left or right any, our X is going to be 0. Now, how much did I have to go up? I had to go up 3A. So my Y value would be 3A. So that coordinate would be at 0, 3a. Let's take a look here at this quadrilateral ECOM, which is a parallelogram with point E located at the origin. What is the coordinate of point O? Okay, remember those parallelograms? Remember what we talked about there? This point M, it had to go over the same amount as this side here. So looking at point M, it had to go over A. So this would be A as well. But to find my X coordinate here, I don't just go over A like point M did. I also have to take into consideration that I shifted over some before I put in the side of the parallelogram. Okay, so this would be my B. So my X value for point O would be B plus A. Now, how much did I go up? What is my Y value? Well, it has to be equivalent to the Y value of point C. So my Y value here was C. So my Y value here would be C. So putting this all together, so we've talked about the distance formula, we've done the midpoint formula, we've done slope. These are all ways to prove or disprove statements about geometric figures in a coordinate plane. So if we wanted to prove that this figure on the graph is a parallelogram. Now, in my head, I'm going, based on what I previously have been taught, I think that's a rectangle. But I can't just say, oh yeah, that's a rectangle. Well, people are going to want to have proof of that. So how can we prove or disprove that this is a parallelogram? Now remember that the sides of parallelograms are congruent. The opposite sides are congruent to each other, okay? So to prove that they're congruent, how can I prove that the opposite side lengths are congruent? By using the distance formula, midpoint formula, or slope. I could use the distance formula, right? For a parallelogram, the key factors is that the opposite sides are not only congruent, but they are parallel to each other. Okay, so how can I prove that the opposite sides are parallel? I can use the slope, use slope formula, or maybe not the formula, but I could find slopes of opposite sides to make sure they are equal or they are congruent. Okay, how would we disprove, or how would we prove or disprove that the figure was a square? We would use the distance formula to find length of all sides. Let's take a look at this example here. It says Becky is writing a coordinate proof to show that the diagonals of a square are perpendicular. She begins by assigning coordinates to the vertices of a square as shown. Which sentence describes what Becky should do to show that the diagonals of the square are perpendicular? Remember, keep in mind, okay, that when lines are perpendicular, they have opposite reciprocal slopes, right? So A says, show that the slope of line SQ, okay, SQ here, is 1, and that the slope of PR is -1. Well, that would be pretty nice, right? Because it would just be the opposite reciprocal. Remember, because you would have 1 over 1 will be changed to a negative, remember, because we change the sign, and then we flip it, 1 over 1. I kind of like A. B says, show that the midpoint of line SQ is the same as the midpoint of PR. So show that they're the midpoint there. Now remember though, up here in the sentence it says, which sentence describes what Becky should do to show that the diagonals of the square are perpendicular? And unfortunately, just by finding the midpoints, that's not going to tell us that our diagonals are perpendicular. Midpoints, they're not helping us with perpendicular lines, okay? So B is out. Show that SQ is equal to PR. Well, hey guys, we could have these two lines right here are congruent to they could be congruent, but that doesn't mean that they're perpendicular. Okay, congruent lines does not guarantee that lines are going to be perpendicular. Show that the line SQ and the line PR intersect at the point A over 2 and then A over 2. Okay, a point of intersection is not going to determine what kind of direction those lines are going. Okay, lines could intersect right here at this point, or they could intersect here. Points of intersection do not guarantee that our lines will be perpendicular. The only thing that will guarantee that our lines are perpendicular are opposite reciprocal slopes. So the correct answer will be A. Okay, make sure you guys are going through the lesson for the coordinate proofs because there's lots of other examples and more information in there. Okay, but this was just a video to kind of give you a brief explanation of coordinate proofs.